Hey, today with my very first detailed video, I've brought you an interesting Math Olympiad problem and its solution. Let's dive in then. This is an inequality problem involving positive numbers. Given that A, B, C, and D are greater than 0, prove that the following expression is greater than 1 and lesser than 2. Okay, now I'm getting started with the solution. If you want to try it on your own, pause the video right here and try it out. Let's get started with the left-hand side proof first, to prove that the expression is greater than 1. The approach I'm thinking is to build up an inequality with fraction terms that have a common denominator, hence to add them up and arrive at the solution. Let's see how that's gonna work. First, consider the very first term in the expression, which is a over a plus b plus c. Let's show an interesting aspect of this term. Since this is a positive fraction, we can decrease its overall value if we increase its denominator, right? The larger the denominator is, the smaller the value of the fraction would be. So, I'm going to increase its denominator by adding a d to it, and this new fraction term would be lesser than the original fraction term, as it has a larger denominator. Hope that's all clear. This is actually the basis for coming up with the common denominator that I spoke about earlier. If you figure it up to now, the rest of it is pretty simple. Now similarly, we'll consider the next three fraction terms of the expression and write the inequalities by creating fraction terms for them with a common denominator. Let's number the four inequalities as 1, 2, 3, and 4 and add them up. It's easy to see that you can add up the four fraction terms to the right as they share a common denominator. We end up with a nice result, a plus b plus c plus d over a plus b plus c plus d, which equals 1. Rearrange the terms, and now we've concluded the proof for the left-hand side. Now we start with the right-hand side proof. Having laid the groundwork, this should be easy. You have to follow the same thinking pattern. Let's start again with the first fraction term of the expression, which is a over a plus b plus c. Since this is a positive fraction, its overall value can be increased if we decrease the denominator, right? So I'm gonna decrease its denominator by removing a c from it to create a new fraction term, which would be larger than the original fraction term. A quite similar approach as our last proof. Now similarly, we'll consider the next three fraction terms of the expression and write the inequalities. Note that, instead of a common denominator, we now have two different denominators. Let's name the four inequalities as 1, 2, 3, and 4 and add them up. Now the first two terms have the common denominator of a plus b, so we can add them up. Similarly, the next two terms have the common denominator of c plus d, so we can add them up as well. We come down to a nice result, a plus b over a plus b plus c plus d over c plus d. It's easy to see that both these fraction terms equals 1 and 1 plus 1 equals 2, hence we're done with the right-hand side of the proof. Okay, hope you learned something and got a chance to admire the beauty of this problem. Kudos if you got to solve it on your own. Let me know your thoughts in the comments section and show your love and support with a like to this video and subscribe to my channel. More cool stuff is coming ahead. Goodbye for today.